update of where we've come from since we last presented in Manchester a couple of years ago. And this is all relating to onboard digital systems and how we can do in-service monitoring with the technology. So 2 years ago, we discussed the art of the possible and what could actually be done with an in-service train. And since then, we've gone on quite a journey. So just to run through that journey and where we've come from. So you'll see back in spring 2021, the idea was first conceptualized of could we bring in-service monitoring to a northern train. So the idea was using the reliable Network Rail monitoring train that's been obviously doing a very good job for a number of years into that, I guess, simplified manner of passenger service. So no longer needing the requirement to adapt and change timetables to actually get to the point of recording the valuable data that the Network Rail monitoring train actually delivers. So from that point, we started working up how that could look and feel, and starting to understand how we can then leverage that data back in to Network Rail to offer that greater scope of data and usability for all teams that actually deliver the infrastructure programs that I guess our customers ultimately want. So as you can see through that, from when we presented only a couple of years ago, we started to identify the key technologies that were required, what the monitoring train delivers, and building on the back of what we've already done as part of the digital train program in Northern, we've been able to adapt that to actually bring to life technologies such as LiDAR, thermal, radar, acoustic, G-Shock bogie, but also G-Shock pantograph as well, which then starts to allow us to get that live data feed, but also the raw data that we can actually start to do trending and analysis around. And that linked into almost the backdrop of everything that the digital train program's been aligned for, bringing CCTV to every single train that Northern operates, making that footage available, but then leveraging that technology to also bring in machine learning and artificial intelligence on the cameras to start and identify vegetation growth, railhead conditions, and a variety of other things that we can machine learn these cameras to do to automate checking. So no longer do we get caught out by the ever-encroaching vegetation issues we have and various other problems that may seem really simple, but it actually means putting a person out there to physically check and understand exactly what the issue is in person. And this is leveraging that technology to allow us then to get hands-on information pretty much live and without the need of a person going on or near the track and then hopefully driving that safety case forward so we can get the intelligence needed to make an informed decision. So after we built up all that information of what we actually needed to pretty much try our best to replicate the Network Rail monitoring train, we built that up into a business case. We started driving forward a series of funding avenues, and Network Rail very kindly funded a series of these. Northern also funded a large proportion of how we can make this happen. And in total, we've invested over £1 million over the last 2 years, bringing this concept to life. And what that's allowed us to do is prove that this technology can be fitted to a train, prove that we can get this information that is collected from the LiDAR and thermal cameras off the train and into a data center that we can then look at. And then how do we then feed that into the tried and tested systems that everyone in Network Rail is very much used to doing? Because we didn't want to reinvent the wheel, because adding in another process or another system becomes slightly laborious in the sense of it's another thing I must learn and another password and everything. So this has all been based around how we can integrate into what is currently there to ensure then that the end user gets a seamless process of data, more up-to-date data, and the ability to request data as well to try and fill in any gaps that could be needed. So jumping forward right through to this year, where we've made a huge leap forward in terms of proving the concept. So funding, as we discussed, was granted to buy the equipment for the train, fit the train, and actually operate the train on a series of test runs. We've also then leaped forward into trying to understand what that can actually mean for industry. And based around that, we were very kindly granted funding for a research paper, which is currently taking place right now and will be due for completion by December this year into January next year, which will start to understand the real benefits of in-service monitoring. In essence, what can we actually stop doing within Network Rail and rely more on technology, or what can we complement current processes with technology and then look into new fields that we've never been able to do before with this type of technology. So part of that process is then looking at how can we make it work for Northern in the north, based on around partnership that we have with TransPennine Express and other operators in the north, to then move forward to understand what that can mean for the wider industry. So if it can be done in Northern, can we almost copy and paste that into a different region, different zone, so we start to build up a standard across the entire network and industry. So just to show the reality, I guess, of this, and we all love a nice cheesy picture on a sunny day. This was taken in Bradford earlier this year on a test run that we did, and the team shown there from Northern, joined by one of Northern's directors, Rob Warnes, who's been our senior sponsor for the last couple of years, promoting this and supporting to ensure that we actually get the focus and deliver this for the greater good. And as you can see in the background, 150-136, which was the nominated train to actually fit this technology on. So as you can see from, I'll go from top to bottom, the nice nose on the train is the radar system. Then to the bottom left of that is the thermal camera. Directly underneath that, hidden behind the coupler, is the acoustic sensor. Then over to the right-hand side is AI 4K cameras, which allow us to see everything that's going on. And then just behind myself is a G-Shock bogie sensor, which is fitted to the bogie before any dampers and suspension and everything. So we get the true interaction between the train and the railhead. And then we've also fitted one after the dampers and suspension, so we can see what the customer comfort element is, because all too often do we get reports from customers or drivers reporting a rough ride, but what is the actual effect from train to track? So we're trying to monitor both aspects of that. So we've done 2 test runs this year with a variety of people from Network Rail and other train companies, just to show how this technology can actually be embedded in an in-service train. And this train has run the network since fitment was first completed early this year, right up to today, and it's still in service running. We do have the ability to log into the train and pull the data. We also have the ability to plug in actually on the train and look at what is going on. And the idea of the concept was to prove that we could capture data. We didn't want to feed that into the wider Network Rail systems to get people, I guess, over-reliant on the data, because we're still understanding whether this will prove to be a viable option. and useful. The data from the research paper that we're currently working through is proving that this will be very useful and be able to complement so many other systems and services as well. And just to go back to the train, not to try and miss any technologies, but right under the radar is the LiDAR system as well. And as you'll hopefully be able to see just under the radar, the LiDAR is actually turned up on its side, because it then starts to allow us to do profiling of the track clips, and it also allows us to do OLE as well, rather than looking straight ahead. So it allows us to do that measurement from the train, so gain a lot of intelligence through this process. So just to recap, I guess the leaps of where we've come in the last couple of years. So Northern's fleet now consists of 334 fully digitalized trains, which consists of over 32,000 assets that we look after. So that can be things like Wi-Fi, CCTV, media screens, obviously to enhance the customer journey. But if you look at what benefits that can actually internally into the rail industry, that brings us over 7,000 CCTV cameras that we can use to improve our day-to-day work and intelligence gathering. And of them, there's roughly 10% that are forward-facing cameras. Every electric train has pantograph cameras, so we can look at the OLE interaction. We can download them, we can live view them for investigations to give our teams greater intelligence when attending site, but also post-incident, we can actually review things much better and faster than ever before. And as we all know, we've got TRU running in the background. All too often, do we get asked in a really positive sense of, can we use your technology at Northern to gather intelligence after major works to stop us walking the track? We've had many requests through in and around Leeds Neville Hill area, where people have asked us if we can pull footage of the OLE sections because work's been done, repairs have been made, and it offers that proof that work's been carried out as expected. So it starts to bring in a whole different process and concept around how we can post-check works, but also how we can remove people from having to walk the track, or ultimately having to take possessions to ensure that work's being completed. The technology is there, it's starting to prove itself, and people are starting to shift opinions in, this is the first and go-to point where I can actually get information around the track and everything that's going on. We're also looking a lot deeper inside. I think it's almost ingrained in every train company, but also in Network Rail as well, about keeping customers informed. So all trains are covered with technology, and we're able then to provide things like GPS back into Network Rail, so we get live tracking of every single train in the entire fleet. So that helps us with timings, sectional run times, and various different congestion elements that we'll look at based around GPS data, and not reliant then on people sitting on trains, gathering recordings, or looking at systems that may not be able to be as precise second by second. It does allow us to capture that. We can also look at acceleration and deceleration profiles with GPS, but also then looking at the full picture, because trains don't always run on nice level track. And it allows us to bring in that data and intelligence to ensure that we can provide that when we are giving times and section times, so we get the more accurate picture. On top of that, we are actually bringing in, and we do have one train currently in, is live OTMR. And what that will do, because it's all familiar now with the newer trains, they come with the capability of pulling OTMR data. But our legacy fleet, and most train operating companies' legacy fleets, almost get forgotten about in that technology era. So Northern has pushed forward with new technology and capability to actually live retrieve OTMR data. And this has currently been on test now for 3 months, robustly on a 158. And we're able to pull all channels from the OTMR. So if we do get an incident where there's an allegation made against infrastructure or train or individual, we're able to very quickly pull CCTV footage, OTMR data, allowing us then to accurately make an informed decision on whether we can continue running trains or past infrastructure and various different signals. And it's proven very reliable over the last few years in the ability to pull footage. But now as we move into the ability to pull OTMR data, it helps bring together that fuller picture of what information we can share.
Sorry, Mark, can you just explain OTMR for there's different people with
Yes,
different experience on the call? Thank you.
Of course. So OTMR is our on-train data recorder. So pretty much the black box for the train. So every train is fitted with that. So it picks up things like speed, brake, horn, and various other aspects. So the legacy fleet trains that are 20, 30 years plus old, they pick up around 40 to 60 different channels. So it can be things like passing, TPWS, AWS, whereas the newer trains pick up over 150 channels of information that's going on the train that could be needed in an investigation. And it allows us then to leverage that back into decision-making process. So within the next 12 months, every Northern train will be fitted with live OTMR links. So we can then start to pull that information into our data centers. We're also then starting to share with the wider industry how we can help other train operating companies deliver that same benefit and leap forward in capability, which should start to bring a more digitalized railway, regardless to when the train was built, which is a big leap forward. So just to jump into the technologies and start to explain, I guess, why we wanted to pick a lot of the things that are actually out there. So most of the technology is mapped around the monitoring train that Network Rail run, but we wanted to then look at what technologies are available with the same output of data. And there was a challenge set in the thermal camera remit that thermal cameras are brilliant, but you can only use them at less than 5 miles an hour. You can't get any real benefit from thermal cameras unless you walk in pace. So we wanted to pick a thermal camera that could be used at full line speed. And in both tests that we've conducted, and you can see from the bottom right picture, all the thermal camera images and tests that were done were up to line speed of the vehicle in question, so 75 miles an hour. And we were still able to very clearly see all images and all recordings, what that technology was able to bring, which means then that the in-service vision is still right there, that we don't need to slow trains down to capture data. The technology has actually grown that rapidly in the last few years that thermal cameras can be used at 80, 90, 100 miles an hour, which makes it available for our entire fleet in Northern. So having that information actually there and available starts to prove that in-service monitoring is very much a strong position forward. And you can start to identify things that even by visual eye, you wouldn't be able to necessarily tell. So if you look at the right-hand picture, again in the corner, you'll see that there's a blue spot in the tunnel, and that's water ingress. And you'd have to have an absolute perfect day, very, very good lighting to actually to be able to identify things like that. And this train was able to pick it up just in passing. And it then starts to identify risk leaders and root cause analysis then in terms of how we can prevent that and how we can move forward in terms of sharing that intelligence. So we're covered then in terms of them tunnel inspections and the harder to reach areas, I guess, that visual eye is never always as good as what some technologies can bring. And it's a huge leap forward then in terms of tunnel intelligence that can be shared. So moving on to G-Shock bogey monitoring. As explained before, we wanted to understand the true interaction between the wheel and the track, because all too often do we pick up after the dampers and shock absorbers and everything, which doesn't give a true picture. Obviously, it's still highly important what is felt inside from a customer experience point of view, and also from a driving point of view, because predominantly they will come from a driver reporting a rough ride, but you will want to see that progressive information build up. And part of this allows us then to profile all the track with that G-Shock entity being recorded, and you can see the build up. And what we can do is start to build in tolerances. And if it goes over that set requirement for the points or the area, it will actually then start to flag, and we can then start to investigate further. And the whole idea behind these technologies is, can it start to spot things early, so we're not firefighting incidents where we've got to hurry up and fix a broken track. Excuse me. And really start to share that so we can plan work. We can then move into that more predict and prevent world, rather than having to close seconds of track to do an emergency repair. It will start to allow to share advanced locking information, and you build that on top of then the LiDAR, because you can see then, is there any track alignment movements from what's before, because the train structure itself will never change. So the measurements can start to be built up pretty accurately. And then you start to layer up that information with things like acoustic sensors as well. It starts to then identify, is there any voids beneath the track bed, or is there any issues with the train itself, like wheel flats? Because if a train's running with wheel flats, we'll know eventually they will damage track, and it's important to flag them as early as possible. So the technology is starting to offer that next level of information for planning, prevention. So we're not having to firefight as much from an infrastructure side, but also a train operating side as well, so we can get trains back in for maintenance planned. And it starts to bring in a greater intelligence then. And as we all know, obviously, acoustic can bring some interesting profiling. You can see below there is a snapshot image of when we were measuring the acoustics, and you can start to then correlate that back into points, back into where the track actually joins. And are we getting different frequencies? Are we getting different noises? How do we get it to machine learn so it can start and tell us if there is a weak spot appearing in the track? And it's intelligence that we've probably never had to this extent and availability, where we can wind on to such a large number of trains to build in that intelligence and data opportunity, because all this information built together just off one train per day generates roughly around 4 terabits of data a day that we need to process. And it's important then that we obviously do that, because as we all know, in train world, we are very much data rich, but we need information to act. And it's important then that we start to feed that into tried and tested processes, methods, systems, and ultimately software that will help everybody top to bottom deliver, obviously, a safer running railway. And that, built in with the technology aspects, will start to give us that advantage piece. And to cover the last picture on there, the LiDAR profiling, you can see there how we can profile the tunnel, for example. And we have picked on tunnels a lot because they're generally not the easiest of things to get into. Usually we have to take full possessions to get in there. This allows us to get that great intelligence in the tunnel, overlay that with things like thermal cameras that we saw earlier, and then you can start to build up that true picture of the integrity of the tunnel. And if there is any works needed in there, it does start to pinpoint exactly where you need that interaction. So just to set this video going, this is a snapshot from the test train that we had running live. You can see the camera that we placed that allows us to monitor the track and everything in front. But the important piece of this is if you see as we just go over the points, you'll see the G-Shock data start to spike. And you can see the correlation then between that and the line above. So the bottom bar that's actually running is the one that's fixed to the bogie before any dampers or suspension or anything. And then you can see the one above that's very slightly less, which is then in the train superstructure after all the suspension and dampers and everything. So it starts to allow us to profile points and profile key areas and junctions and various different aspects around the track that could be of interest. And we can start to set a threshold because all of these measurements can be built in to tolerance levels and then built up. As you can see, it G-shocks right up to 20 on the scale. And what we can do is if it goes over 20 for that particular set of points, it can flag and it can build in. But we also need to profile that, is there a speed correlation as well to it? Is there a passenger loading correlation to it as well? Because obviously a heavily loaded train will act differently to a empty train. And it's important we start to build in them tolerances when we're learning this type of information to what it could actually mean in terms of sending an individual or a team to that set of points to fix it if the technology is telling us there is a tolerance impact. So that will all be part of the plan to ensure that all data is captured and we start to overlay a series of other data entities so we're getting that truer picture. So if somebody is being asked to go and respond to these set of points and actually do work, was it because the train was acting right? We'd hate to send people out wrongly. So this has to complement, this has to offer a new information stream to allow people to act more appropriately in terms of responding, and then we can plan works in much better. And that will then start to build up through the work that we're doing as part of the research paper. And that research paper has been pulled together jointly by Northern, by TransPennine Express, by Network Rail, but also by Huddersfield University. So we get that academic view of what we're actually delivering and what we promised to deliver as part of it. So if we said that this new G-Shock bogie will help replace visual checks, how and what's needed to ensure we do that? If we say that this technology fitted to a full train, demonstrated earlier, can help reduce the requirement of Network Rail monitoring train visiting the track, we need to prove that. And that's all part of the research paper to ensure if we move to this, is it equal or better? And ensure that we leave no gaps, because it's important we get that full data coverage so people are informed when they're doing future works. So just to run through briefly on this, I won't read them all out because there's lots of pretty colours on here. But it's just to identify what technologies can actually be brought in, to what impact they will have to service and infrastructure, and how that will actually correlate back into usable cases for us to do. So it's been split down into track operations and OLE, and you can see that there's nothing in the low impact, low simplicity of technology banding. So what it starts to demonstrate is all the technologies that's been chosen offer a benefit, and in most cases they offer a high benefit in return of actually being fitted to a train. So you can see we would start to reduce the requirement on vegetation assessment, on rough ride monitoring, on train location and incident response. We will be able to look at door operations and track gauging, all based around this technology. And then when we move into the OLE world, there's obviously big cases we never want to pull overhead lines down. How can we start to prevent that? So we're also going live in a couple of weeks on pantograph G-Shock monitoring. And again, that will be able to profile the interaction between the train pantograph and the OLE and be able to map that through in terms of G-Shock profiling on top of all the other systems that we've now got fitted. So we have fitted pantograph cameras, but we're also going through a program which will be completed hopefully by March, energy metering, which actually starts to monitor all the electricity throughput and ampage of each individual train. So if we do get things like arcing and spikes and various other things, we're able to see that straight away and report that back in. We can see then and identify is the things obstructing the OLE, because we don't want things tangled in the OLE that could ultimately result in it being pulled down. And we can start to monitor, as we did this year, the tension on the wires and weights. So we're able to use forward-facing footage to feed into an analytical program to measure the weight and tension on each of the OLE stanchions. And again, that previously would have been done by a person checking, and we're able to do that just by requesting the footage and feeding that into a technology that allows us to pretty much measure the weight displacement due to the high temperatures. So it's a real good use case of how we use technology in today's world of trying to keep our highly qualified engineers making informed decisions without having to drive or walk half the country to figure out that decision-making process. So last slide, and I promise I will take questions. So just to, I guess, summarise the benefits and what we believe this will bring, and the ultimate thing that's, I think, strong in all our hearts is boots off ballast. If we don't need a person on the track, let's make sure they're not on the track. That will then start to drive safety, and we ultimately want people to feel that they can get the right information through this technology without being stood on the track. So that is a big leap forward. We're going to be driving in improvements in performance. There'll be less disruption to service as well, because as we all know, there's generally blockades and various things put in at weekends to ensure we can get in and check the track, make sure that it all looks and feels the part, so we can then run a weekday service as expected. And as everybody has seen over the last few years, times are changing. Sundays are incredibly busy now, and so are Saturdays. And people want trains more often and at very different times. So the more we can use technology to reduce the requirement of inspection and reduce the requirement of having to send specialist equipment and people down the track when there's no trains running, it helps ultimately the PR machine of the railway to get people travelling. But it also helps in the fare box, as brutally as that says, because if people like travelling on trains and it's reliable and there's less cancellations and delays, people will come back. And it builds that advocacy profile of travelling by train and making it more efficient and more reliable, that trains will run as expected and to plan. So there's so many things in there. We do move into a whole world of big data, and that's when we move into a world of metadata and prediction. So as we start to build up all this information from these trains, it allows us to build it into prediction models and various things to allow us to build up them tolerances and enable them people to foresee incidents coming weeks, months ahead of what we may have been able to do in today's world. And that's all because we're going to be collecting these vast sums of data that will then start to be analysed and processed, so we can then be there 2, 3, 4 weeks before a predicted incident could happen on a broken rail or an OLE problem, a problem tree that might be growing. We can then start to intervene at the early stages to ensure that we reduce delays and we're not calling people out in the middle of the day, middle of the night to respond to incidents, when we can do it all through a planned process. And the ultimate goal is all around customers, to ensure that we reduce the amount of times people come to catch a train and they end up on a bus. That's never fun, I think, for people. And obviously a reduction in the advocacy element of people having a bad journey. All too often do we see train disasters journeys on TV where it's just not worked as planned, and we do try our very best. This technology will enable us to do even more and to prevent a lot of them aspects again happening in future. On that note, any questions?
Thank you, Mark. There is one question in the chat from Mark Stowell, who's put in as part of the G-shock bogie monitoring, does the train have auto measurement of the passenger loading to help inform asset measurement tolerance levels?
Yeah, really good question. So Northern's fleet is now fitted with passenger counting technology. So we can see on every train live counting. So that is a capability that's there. So the idea of layering up the different aspects around data for infrastructure, we can also do that with regards to passenger loadings as well. So that's all part of the big data piece that we're working on.
Brilliant. Is there any other questions from people on the call, or I'll squeeze in a couple? Just one observation from myself is that the thermal and acoustic monitoring, I just thought you just use it for what the output is, but you're obviously trying to utilize it for combining it together and finding different benefits. Is that, are you kind of driving that, or is it discussions with other people like Huddersfield University? How's that panning out?
So everything that we've done throughout this project is wanting to drive change, but I think you can only drive change by actually speaking to the people that have to deliver these type of pieces of work. So we've reached out as far as we possibly can do within Network Rail and said, what do you need to do on a day-to-day basis to keep infrastructure working? Do you have to walk the track? What do you check? How do you check a tunnel? How do you check a ravine that's really difficult to get in? And the almost frustration, I think, in that is that if I need to check this piece of infrastructure, I have to stop a train. And that, I think, annoys the artisans doing the work, but they know it's so important to go check that entity. But leveraging that information that the thermal and the LiDAR and various technologies can offer, they don't need to stop a train anymore or have to go out in the middle of the night to check the infrastructure when no trains are running. The information's available, and the process with this is aiming to fit enough trains within Northern that every piece of track would be seen at least once or twice a day. So we get the rotation right. So we go from having the monitoring train doing it maybe once every few weeks, few months, to almost every day. And the flexibility within it, if we fit enough fleet, is that if you pick the phone up and said, Mark, I would love a train in the next few hours to be going over this section of track because I need an inspection right now, we can then hopefully position ourselves with our control to go, can we get one of these units over this piece of track, because Mr. Woods would really love it. And it gives us that opportunity to do that and be flexible in terms of information delivery, that within your request, within a couple of hours, you've got your information. You're no longer waiting for hours or stoppages or whatever. So it allows us to bring that live almost to yourself.
Right. No, thank you. Anyone from a question from people attending today? Come on, you must have a question. No, not even a snippet.
They're either asleep or amazed.
Oh, there we have. We've got one there. Rob's coming with one. Rob, go on.
Yeah, just a quickie. The amount of data is mind blowing. How long can we store it for?
Good question. So obviously data is massive and it's not easy to basically transfer from a train into a data center. So part of the research paper is not just looking at how many trains should we fit to the fleet. We're looking at what technology needs fitting to drive a benefit. How do we then get that data off the train? So we're currently going through trials in our depots and major train stations where we can link up to the Wi-Fi and fast offload that information all throughout the day. So we're not relying on mobile phone coverage, because we all know that can be rather patchy in some places. But what it does is when the train pulls into Neville Hill or Leeds or Newton Heath, it will have a dedicated Wi-Fi network that will be able to offload that information. And in the next few weeks, we're going to be testing the capability to push us up to a gigabit upload per second to allow us to work that through. So data is very mindful in our process when we walk through that. So there's no point capturing all this and storing it on train for a few days. We want to be able to upload it. So if that request does come in from yourself, David, we can get it off and get it to you as quickly as possible, processed, so you can then take action, review, and whatever you need to do with it. And we've realised very much so in Northern, we're very good at running trains. Infrastructure is your job. Let's get you that information to help you do your job.
Okay, brilliant. Just got a couple of questions coming now. Bissell, he's put a question about when will the pantograph G-Shock monitoring start? Is that available now, that data?
So that's getting fitted in early mid-November, and it'll be fitted to a 3-car 331. And then the data will be available for us to pull that off, analyse, see how that looks, how that interacts. We have done testing on depot. We did that at Allerton roughly 9 months ago, and that started to pick up already actual problems in the reception roads in Allerton. So the technology is looking promising in that. So once we're up and running in a few weeks, we'll be able to share that data.
Brilliant. Okay. Tom's got a question. Is there anything else that could be measured? But it does seem pretty comprehensive now. Is there anything else you'd like to add to this?
There is a few other technologies we are looking at in terms of feasibility, like ground penetrating radar, things like that. But what we wanted to do is start with the baseline of what could keep our trains running ultimately in terms of what can be seen. Then the idea is that we've got the building blocks on the train already in what we've installed over the last few years. We then complement it with this technology. Then what's next? And it's a constant evolving drive for improvement, I think. So if a new technology comes along tomorrow that can detect new things, we will absolutely be there to look at it, to understand what that can drive for performance benefits and driving that efficiency profile for us as an industry.
Brilliant. Okay. So yeah, just see where we are. So I'll probably just bring the meeting to an end. But first of all, thanks again, Mark. Fantastic. Well, very inspiring presentation. Some of the technology there. If that is available 1 or 2 times a day on any of the Northern route, that's amazing information that would be fantastic for us to use, both as you kind of alluded to from a construction, what we've done, or assessing what we need to do, or even during the staging elements. So yep. I won't disappoint you by saying, is there any time I can access this data? I'll be, really interested in trialing it if possible. Obviously, other people are trying to do similar things, and it's good that you're working together with TPE and Network Rail as well. And I'm going to try and put a pen in here, but I commend your tunnel vision and focus on developing this technology. There we are. What about that? So I don't know if you could do virtual applause or whatever you want to do. And thank Mark for his presentation today. Thank you.
No problem.
Mark, one